In this video, we will use the law of sines and the law of cosines to find missing sides and angles. Now, whether we will use the law of sines or the law of cosines depends on what type of information we are given. If we are given angle, side, angle, we're going to use the law of sines. If we're given side, angle, side, that's going to be law of cosines. We will also use the law of sines if we're given angle, angle, side. We will use the law of cosines if we are given side, side, side. So that just leaves the ambiguous case. I'm just going to put a little star on this one. The ambiguous case is side, side, angle. If we're given side, side, angle, we will use the law of sines. So your first job is to glance at the information and decide: do you have angle, side, angle? Do you have angle, angle, side? What do you have? So I see that we have two angles and a side. So that means it's either going to be angle, side, angle, or it's going to be angle, angle, side. Either way, we're going to use the law of sines. Okay, so we know that right off the bat. And we also know it is not the ambiguous case. So we can just go ahead and start solving the problem. Okay, let's make a list of what we're missing. We need to find the measure of angle C, right, because that's the one angle that's missing. We need to find the length of side B, and we need to find the length of side C. So I like to make a little box and put it off to the side, ready to record these things as we find them. So let's draw a picture. So here comes triangle ABC. We're told that angle A is 54 degrees. Angle B is 28 degrees. All right, and then across from angle A will be side A. Well, actually we know that that's 12, so I might as well just put 12. But across from angle B should be side B, and across from angle C should be side C. Okay, well, let's just go in order down the list. So first I want to find the measure of angle C. Well, that's going to be easy because we already have 2 out of 3 angles given. They have to add up to 180, so I don't need to do anything fancy. I just need to do 180 minus these 2 angles. So minus 54 minus 28. So that's 98. Okay, so the measure of angle C is 98 degrees. All right, now I'm going to go after side B. So here's what the law of sines looks like. Side B over the sine of angle B should equal side A over the sine of angle A. All right, I'm only going to write that down one time, but I'm going to go ahead and fill in because we know that angle B is 28, and we know what side A and angle A are. So angle B here was 28, and side A was 12, and angle A is 54. Okay, so if I multiply both sides by sine 28, okay, if I were to do sine 28 on both sides like this, all right, then these will cancel, and this is going to give me the value of side B. And I'm just going to put this entire thing in my calculator. So I will do 12 sine 28 over sine 54. Okay, so that is it. 6.964. Got to round up. All right, now I need to find side C. Okay, so for side C, I'm going to do the exact same thing. I'm going to put C over the sine of C, which is 98, is going to equal A over the sine of A. So that's going to be 12 over the sine of 54. So if I multiply by sine 68 on both sides, I'm sorry, sine 98, then these will cancel out, and that will give me side C. Side C will equal this. Okay, so 12 sine 98 over sine 54. Okay, so 14.688. And that's it for problem number 43. For number 44, we are again given two angles and a side. So I know I'm going to use the law of sines again. And this is not side-side angle. It's not the ambiguous case, so I can just solve this normally. So what am I missing? I am missing the measure of angle C. I am missing side A and side B. So I need to find out what is side A and what is side B. So here is my answer box, ready to go. Now, here's a picture. Okay, so here's triangle ABC. Okay, and they gave me angle A is 72, and angle B is 48, and side C is 8. Okay, first let's find the measure of angle C. That will be super easy because they gave me 2 out of 3 angles. They have to add up to 180. So if I start with 180 and I subtract 72 and I subtract 48, that leaves 60. So the measure of angle C is 60. Next, I want to find the length of side A. And this is side A right here, across from angle A. Side B is here, across from angle B. So whatever I'm looking for, I always put that in the numerator. So the way the law of sines works is side A over the sine of angle A. So the sine of 72 will equal, all right, and I'm looking for a pair, a side and angle that I have both of these. So side C over the sine of angle C. So side C over the sine of angle C. So this is my equation. If I multiply both sides by sine 72, these will cancel out, leaving A by itself. Okay, so 8 sine 72. So 8 sine 72 over sine 60. $8.785. All right, and finally, side B. And again, whatever I'm looking for, I put that in the numerator. So that's going to be side B over the sine of angle B, which is 48, will equal side C over the sine of angle C, which is 60. And once again, I will multiply both sides by sine of 48. So these will cancel out. Okay, so I've got 8 sine 48, 8 sine 48 over sine 60. Okay, so that's 6.865. Got to round up. 6.865. And that's how it's done. Now, when I look at number 45, I notice that we have two sides and an angle. So that means this is either going to be side-side angle, or it's going to be side angle side. If it turns out to be side-side angle, then I'm going to wind up using the law of sines. If it turns out, and that's the ambiguous case, all right, the one that's a little bit crazy. If it turns out to be side angle side, then I will use the law of cosines. Now, I have a little shortcut for knowing if it's side-side angle. If I have two sides and an angle, and the angle matches one of the sides, then I know it's going to be side-side angle. So this is the ambiguous case. So here's what I recommend. Start by writing down the angles and sides that you need to find. Because it is the ambiguous case, there's going to be two triangles. That's why I wrote down angle B1, C1, and side C1, and angle B2, C2, and side C2. All right, that's to represent the two different triangles. So let's draw the first triangle over here. When you have the ambiguous case, you've got this one angle. What you want to do is always put the angle on the left. Okay, so the angle will go right here. So this is going to be angle A, and I'm going to go ahead and call this 40. Show this side as a dotted line, because this is the ambiguous line. All right, picture this as a rope that swings back and forth. Anyway, that's side A, so this will be 4. You should let the other side they give you, this 5, be this side on the left. So this is going to be 5, and that's side B, which makes this angle B, which makes this angle C. So let's go ahead and solve this triangle using the law of sines. So let's start by finding the measure of angle B. Let's start by finding the measure of angle, well, B1. So because I'm looking for the measure of angle B1, I'm going to put that in the top. So I'm going to say the sine of B1 over side B, which is 5, will equal, all right, the sine of 40 over 4, because that's the law of sines. Now, if I multiply both sides by 5, like this, then these 5s will cancel each other out. So that's going to give me, that's going to leave the sine of B1 is going to equal all this. But I really want the measure of angle B1 itself. So that's going to be inverse sine. So if I do the inverse sine of all of this, so the inverse sine of 5 sine 40 over 4, that should give me the measure of angle B1. All right, so here goes the inverse sine of 5 sine 40 over 4. So that's 53.464. I should now easily be able to find the measure of angle C1 because now I have 2 out of 3 angles. So I can just move this out of my face, first of all. Let's see. All right, so if I start with 180 and I subtract the 2 angles that I have, so subtract 40 and subtract 53.464. So 86.536. All right, now it's time to find side C1 using the law of sines again. Okay, so side C1. So because I'm looking for side C1, I put it in the top. So C1 over the sine of angle C1, so that's 86.536, is going to equal, and I'm going to use this pair again, but this time I'll do side A over the sine of angle A. All right, and so I need to multiply both sides by the sine of 86.536. So the sine of 86.536. Because that way these will cancel each other out, leaving C1 by itself. So I'm just going to put all of this in the calculator. So this is going to be 4 sine 86.536 over sine 40. So that is 6.212. Got to round up. Now it's time to draw the other triangle. I'm going to draw the other triangle by taking this rope, this dotted line, and swinging it inward to make an obtuse triangle. So that's going to look like this. All right, so it's going to start off the same way. All right, I still have this angle. Okay, so I still have angle A in the exact same position, and that is 40. But this time I'm swinging the rope inward, so it's going to be like this. So this is going to be my angle C2 and my angle B2. All right, but this is still 5, and the rope is still 4. It has just swung inward. That's the only change. So I need to find these now. Now the key is the relationship between angle B1, I should put some ones up, and angle B2. These two angles are always going to be supplementary. So I'm going to just subtract from 180 to find the measure of angle B2. Okay, so if I simply do 180 minus the measure of angle B1. So minus 53.464. That gives me angle B2, 126.536. Okay, so that is this angle right here, 126.536. So again, I have 2 out of 3 angles now, so I should be able to find the third angle by subtracting from 180. Okay, so if I do 180 minus 40 minus 126.536, all right, that's giving me 13.464. Okay. All right, and that just leaves side C2 is the only thing left for me to find. So, since I'm looking for side C2, I'm going to put it in the numerator. All right, so I'm going to do side C2 over the sine of angle C2, which is 13.464. All right, and again, I'm going to use the 4 and sine 40. So that's going to equal 4 over sine 40. So I can get C2 by itself if I multiply both sides by the sine of 13.464. Okay, because now these will cancel each other out, and that will leave C2 by itself. So all I have to do is put this in my calculator. So I have 4 sine 13.464 over sine 40. Okay, so that is 1.449. All right, so side C2 is indeed very tiny. But that's it for number 45. All right, guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.